Okay, to start off our notes for trigonometric ratios, we're going to do a little bit of a review and kind of go through the different methods we would use for solving pieces in these right triangles. So if we look at questions number 1 and 2, if you notice, we have a right triangle that has that altitude drawn in. So we actually have the geometric mean to use. So for number 1, we would use that 4 over x equals x over 5. That would be my setup for the geometric mean. Okay, so then for number 2, same kind of thing. Again, that side of the big right triangle is going to be my geometric mean. So we would actually do, we could say 5 over x is equal to x over this large side right here, which is going to be 9. Okay, so for numbers 1 and 2, the method we're going to use is the geometric mean. All right, now if we come down to 3 and 4, you can see there that now this time we don't have that altitude drawn in. So what we have here are 2 out of the 3 sides. So for this one, when we know 2 out of the 3 sides for a right triangle, we can just use Pythagorean theorem. So we would label our sides. Let's see, right here is my hypotenuse, and then I have my sides A and B. Here's my hypotenuse, and then we have A and B. So we would set up, instead of a squared plus b squared equals c squared. For number 3, we would put in 12 squared plus 5 squared equals x squared and solve it from there. We're not going to solve all of these, we're just kind of looking at the different methods. So same thing for number 4, a squared plus b squared equals c squared, and we would plug in my 8, my 5, and my x. So again, that's our Pythagorean theorem. And that's when you have 2 out of the 3 sides for a right triangle. Numbers 5 and 6, these ones are a little bit tricky, but these are our special right triangles. So when I know that I have a 45, 45, 90, I know that this side over here is going to be equal to 6, and my side across, my hypotenuse, is going to be 6 radical 2. And then here, for my 30, 60, 90 triangle, I know that to get from my long side to my short side, I'm going to divide by square root of 3. So I'm going to just have 4 over here. And then to get from the short side to the long side, I'm going to multiply by 2. So that would give me 8. So those are special right triangles. And then lastly, we're going to look at problems 7 and 8. Now, here's where we get a little bit stuck. For 7 and 8, we have one side and one angle. And this is not a special right triangle because it's not 45, 45, 90, and it's not a 30, 60, 90. So this means we're going to have to use a different method. So we're going to have to come back to this one in a moment. So the first thing we need to do is talk about a little bit of vocabulary. Number 1 here says label the triangle leg, leg, and hypotenuse. So we're going to start off, I always like to do the hypotenuse first. Again, that's across from the right angle, it's the longest side. So this one, side BA, is my hypotenuse. And then the other two sides are going to be my legs. So BC I can label as a leg, and CA I can label as a leg. Okay, so now we're going to write down what the actual names of those sides are. So for my hypotenuse again we said is BA, so we're going to go ahead and write that down. Hypotenuse is BA. And then we want to look at what is the leg that's opposite of angle A. So here's my angle A. Opposite of that, I have leg BC. I should have drawn a line over that for our segments there. Okay, the leg adjacent to, adjacent means it's next to it. If it's adjacent to angle A, and we're talking about the leg, see how there's 2 sides adjacent, the hypotenuse and the leg? If we're not talking about the hypotenuse, it means it must be CA. So the leg adjacent or next to angle A is CA. That means it's touching it, it forms that angle. The leg opposite angle B. So if I stand here at angle B, what is across from me? What side is across? Well, that's leg CA. So opposite of angle B
if that's my point of reference, across from me is CA. The leg that would be next to B, or that helps form angle B, would be right here. See how BC is adjacent? It's next door to B right here. So that would be leg BC. So there we go. Those are the big three terms that we need to know: hypotenuse, opposite, and adjacent. So now we're going to move on to number 7 through 10 and put some numbers with it. So again, number 7 says label the sides with H for hypotenuse, O for opposite, and A for adjacent. And this is if we put our pencil on point G. So you know what I'm going to do? I'm going to go ahead and just draw a little stick figure. If I'm standing here on point G, I want to label my opposite side as O. So if I look across, my opposite side from me is going to be right here. My adjacent side is whatever's right next to me, but isn't the hypotenuse. So actually, let's look at the hypotenuse first. My hypotenuse is that longest side, and it's always across from the right angle. Always across from the right angle. So that's my hypotenuse, that's my H, which means we only have one spot left to have that adjacent side. The side that's right next to me that forms my angle is going to be right here. So this is my adjacent side. So let's go ahead and write those using the G, H, and J. So the measure of the hypotenuse is 41, right? That's my side right here. This is my hypotenuse side. So the measure of the hypotenuse is 41. The measure of the side opposite of angle G, my opposite side over here, is 9. And the measure of the side that's adjacent to me right now at angle G is 40.
Okay. So there are special trigonometric ratios that exist among the sides of right triangles, and that's called sine, cosine, and tangent. Okay. So the sine of angle A is always your opposite over hypotenuse. The cosine of your angle A is always the adjacent side divided by the hypotenuse. And the tangent side, or the tangent of angle A, is always your opposite side over the adjacent side. See how we just shuffled those around for each one? So that can get kind of confusing, right? So how do we remember that? Well, you've probably heard people talk about SOHCAHTOA before. SOHCAHTOA. The reason geometry teachers like to use SOHCAHTOA is because it helps us remember what those ratios are and how to use them. So anytime you think of SO, it's opposite over hypotenuse. That or cosine is adjacent over hypotenuse. And the tangent, my TOA over here, is opposite over adjacent. So that's how we remember the ratios for sine, cosine, and tangent. You spell out sine, or SOHCAHTOA for sine, cosine, and tangent. So we're going to do a little bit of practice with figuring out what those sides are for sine, cosine, and tangent. What I always recommend is writing that SOHCAHTOA at the top of every worksheet like this, just to remember. SOHCAHTOA. And again, the S stands for sine, the C is cosine, and the T is tangent. All right, so for number 1, if I'm starting with the sine of A, that angle they put there is always your point of reference. So we always have 3 angles in a right triangle, obviously, but you know where to stand based on what the problem is telling you. So here we have sine A. So if I'm standing on sine A, I know that for sine, I'm looking for opposite over hypotenuse. So I can even write opposite over hypotenuse, O over H. What is my opposite side from angle A? What's my opposite side? Right here, I have 5 across from me. So the opposite side is 5, and the hypotenuse is 13. So the sine of angle A for this problem is 5 over 13.
If I want to look at the sine of B, so this time I'm standing on angle B, the side that is across from me is 12. My hypotenuse is still the same, it's still across from the right angle, so it's 12 over 13. So see, it changes depending on where you're standing, where your point of reference is. So let's try cosine. My cosine of angle A, again, I'm going to use this ratio up here, the adjacent side over the hypotenuse. So adjacent over hypotenuse. Now we need to figure out what those sides are. Well, if I'm standing on angle A, I know that the hypotenuse is the side across from my right angle. So this is my hypotenuse right here. That's my H. Which means my adjacent side is the other side that forms that angle. It's going to be right here, which is 12. So the cosine of angle A is 12 over 13. Same thing for angle B. If I stand here at angle B, I need my adjacent over hypotenuse. I know the hypotenuse is always going to be that 13 right there for this triangle. The side adjacent to me that helps form my angle B is this right here, which would be 5. So my cosine of angle B is 5 over 13. Lastly, for tangent, I know I'm going to use opposite over adjacent. So now for angle A, if I were to stand on angle A, I would do the opposite side, which is across from me, at 5, over the adjacent side. So the adjacent side is the other side that forms my angle and is not the hypotenuse. So that's going to be 12 right here. So my tangent of angle A is 5 over 12. For angle B, if I were to stand on B, the opposite side from me is 12. And the adjacent side is that other side that touches angle B and is not the hypotenuse. That would be 5. So there are my ratios for this triangle depending on which angle you're standing at. Okay, so I'm going to pause it right here. I want you to try to label, find the different ratios for number 2, for the triangle here, number 2. In the next section, you're going to see the answers there, okay? So you can check your work when you're done. Okay, so here are the answers for number 2. Number 2, we actually had to do a little bit of work before we could set up the ratios. So we had 2 out of the 3 sides for this right triangle, which meant we could use Pythagorean theorem. So over here in red, I used my Pythagorean theorem and plugged in the 2 legs and just simplified for that hypotenuse. So we got 25 for the hypotenuse. So that's what we should plug in. Anytime you see an H there, that's what we should have plugged in. So you can go ahead and check your work for the sine of angle A and B, the cosine of angle A and B, and the tangent of A and B. Okay? So when we're using these different ratios in the calculator, it's really important that we have to be in degree mode. So I'm going to show you how to do that. If you go to mode on your calculator, you come down, it's kind of hard to see on here, but you're going to go down, for me it's the 4th line, and instead of radian, I'm going to select degree. Okay, if you don't do that, you're going to get all sorts of crazy answers that won't work, that will give you the incorrect answer. So again, make sure that your calculator is in, I'm going to use a different color here, your calculator should be in degree mode, and we will talk about that all year long, okay? So it should be in degree mode. So in your calculator, what you're going to do is type in the function and then the angle, okay? Type in calc. So like for this one, we'll just do function and then the angle. So whatever x is, I'll just put in it right here. So for number 1, I would do sine, which is right here. I would do sine 30, close parentheses, and press enter. And I'm going to round to the nearest hundredth, so 2 decimal spots. So for this one, the sine of 30, we would just say is 0.5. For number 2, I have the cosine. Cosine's right next to sine, so I would do cosine of 45, press enter. And again, we're going to round it to the nearest hundredth, so that's 2 decimal spots. So I would have 0.71 for the cosine of 45. So 0.71. And then last one we have here for number 3 is tangent. So tangent of 60, press enter, and I would have 1.73. And that's it for how you're finding the calculator. We're going to skip number 2. We're going to work on that tomorrow. So let's go ahead and move on to the next page. Okay, so we're going to do a couple of practice problems now, putting it all together.
So the first thing we're going to do, it says find the value of the variables, round to the nearest to the nearest tenth, and put a box around your answer. Okay, so we're going to start with number 1. First, it's always good to look at what method you need to use. Okay, here I have an angle and a side, which means I can't use Pythagorean theorem. This is not a special right triangle. I can't use geometric mean, so I know I'm going to have to use my trigonometric ratios. So I'm going to write at the top, SOHCAHTOA, every time so I don't forget. Okay, SOHCAHTOA. So the only angle I'm given is 25, so I'm going to start off by drawing myself down here at my 25-degree angle. Okay, and I'm going to label my sides. So I have my opposite side over here is X, right? That's the side across from me. So I'm going to label that as O. And the side right next to me, I'm going to label as A. That's my adjacent side. So I have two sides that I'm trying to look for, or the two sides that I have here labeled. I have my opposite side and my adjacent side. So I need to figure out which trig function can help me find X. Which trig function uses O and A? So if I look up here, the one that has O and A is tangent. So I'm going to say the tangent of the angle I'm standing on, 25, tangent of 25 degrees, is equal to my opposite side over adjacent side. So that would be my X over 5. Okay, so take a minute, make sure that makes sense. We're starting off by writing the tangent in terms of the angle we're standing on. So tangent of angle 25 degrees is equal to my opposite side over adjacent side. Okay, so now that we have this set up, all we have to do is solve for X. So if I want to get X by itself, I need to get rid of that 5 down here. So all we're going to do is multiply by 5 on both sides. Okay, I multiply by 5 on both sides. I get rid of my 5's here. Now I have X is equal to, and here's where our calculator comes in. Okay, I'm just going to type this in exactly as I see it. 5 times the tangent of 25 and close my parentheses. And I get 2.3. So X is about 2.3 because it said round to the nearest tenth, right? So that's 1 decimal spot. Now you could have also done it, you could have typed in tangent first, tangent of 25, and gotten your answer, and then multiplied that by 5 and gotten the same thing, 2.3. So either way you want to go about it is fine, but our answer here for that missing side length is 2.3. Okay, so let's try number 2. So for number 2, again, I have an angle and a side. It's not a special right triangle, not geometric mean, so I have to use a trig function here. So I'm going to draw myself on my angle, my point of reference, and I'm going to label the sides that I'm given. So across from this right angle, that's my hypotenuse. And then the side that's next to me is going to be adjacent. So the two sides that I'm given are the adjacent and the hypotenuse, which means I need to find the trig ratio that would incorporate the adjacent and hypotenuse. And that's going to be cosine. So I'm going to write my function in terms of the angle that I'm standing on. So cosine of 55 degrees is equal to my adjacent side over hypotenuse. So 10 over X. Okay, so I need to get X by itself. Now, this is kind of a weird way of doing this. We could go out and multiply by X on both sides, and then we would actually divide by cosine of 55 on both sides, right? But there's a shortcut for that. Instead of having to write out all that work, anytime you see X in the denominator, we're going to switch that X with whatever on the left side. Okay? Again, if we were to multiply by X on both sides, we would have X cosine 55 equals 10. Then we would have to divide by cosine of 55, right? So we'd be left with X equals 10 over cosine 55. Really, those are just swapping places. So we're going to write it like this. X is equal to 10 over cosine of 55. And that's it. So now we get to use our calculators. And I'm going to go ahead and do my fraction function here. Alpha y equals to get a fraction. And I'm going to type in 10 on the top. And on the bottom, cosine 55, enter, and we get X is approximately 17.4. That's the length of that hypotenuse. Pretty cool, right? Number 3 is a little bit different. Do you see how we're given two sides and we're trying to find a missing angle? If we're trying to find that missing angle, we're going to do it a little bit differently. We're going to talk about that more tomorrow. So I'm going to go ahead and circle this one. This is something we're going to touch on in our next lesson. But if I look down at number 4, I see that I have an angle and a side, and I'm going to have to use one of my trig functions. So again, I'm going to start off drawing myself in the angle, and then I'm going to label the sides. So the sides that I'm given here across from my right angle is my hypotenuse, and the side that's right next to me here, we call that adjacent. So now I have the adjacent and the hypotenuse side, which means, again, I'm going to use my cosine function. So I'm going to say the cosine of the angle I'm standing on is equal to my adjacent side, which is 8, over my hypotenuse, which is y. Okay? Again, I have that variable in the denominator, so just like number 2, those are going to swap places. So to simplify this or solve for y, we're going to swap places. My y is going to go on the left, and now I'm going to have cosine of 40 on the bottom. And again, I do alpha y equals to get my fraction, and I'm going to type in 8 over cosine of 40, and we get about 10.4. So y, or my hypotenuse for this triangle, is approximately 10.4. All right, so number 5, again, we have two sides. We're looking for a missing angle. This is one of those problems we're going to look at in the next lesson. And the same thing with number 6. We're trying to find a missing angle. So the last one we'll take a look at is down here for angle 7. It looks like number 7. Looks like we have two variables to actually solve for this one. So if I have my angle 36 degrees, right? I'm going to go ahead and draw my little person there, my stick figure. And I'm going to start by solving for x. So if I'm solving for x, that means that x is the side that is opposite of me. And 10, that's across from the right angle, so that's my hypotenuse. So to solve for x, I'm going to use sine, because it has opposite and hypotenuse. So I'll write the sine function of 36 degrees is equal to my opposite side, which is x, over my hypotenuse side, which is 10. To get x by itself, we're going to multiply by 10 on both sides to get rid of the 10 right here. And I'm going to multiply this whole side by 10. Those cancel out. So now I will have 10 times the sine of 36. I'll put 2 parentheses there to close it. And I get 5 point, if I round that up, 5.9. So x is approximately 5.9. And then I also need to find my hypotenuse side. Or I mean, not my hypotenuse side, my y value there. So if I need to find y, the y side is actually adjacent to me. So I can use, you could either use x that we just found, which is 5.9, or we could use a 10. I would say go with the 10 because it's a whole number, it's more exact. So I'm going to use my adjacent side and my hypotenuse side. Okay, so that means we're going to use cosine. So I'm going to say the cosine of the angle I'm standing on, 36, is equal to my adjacent side, which is y, over my hypotenuse, which is 10. And again, to solve this or get y by itself, I'll multiply by 10 on both sides. Those cancel out. So now I have y is equal to, let's try this, 10 parentheses cosine 36, and we get 8.1 when we round that. So that's how we find the two lengths for that right triangle there.